So today we're talking about the chi-square versus t-student versus f distribution and when to use each of them. So the first one we're going over is the chi-square distribution, and we want to use this distribution when you're dealing with categorical data. This categorical data can be either two things, nominal or ordinal data, where nominal data are named and have no inherent order. So for example, we could have our colors of red, blue, and green, or just types of pets, while our ordinal data has a meaningful order or ranking, such as your education level, where you have high school, bachelor's degree, master's degree, and PhD. And then the next thing is you're interested in comparing the observed frequencies in the categories to expected frequencies. And then you also want to test for independence between the two categorical data, because in order to use the chi-square distribution, you have to have both of your variables as independent. And finally, you need to compare the variance of a sample to a known variance. So some clues to look for when you're doing a question to know that using a chi-square distribution would be using counts or frequencies. If you're testing for associations or differences in categorical data, and you see terms like observed frequently, expected frequency, or contingency table. And now finally, in order to use the chi-square distribution, some information that is needed is you need the observed frequencies, which is the counts of something. You need the expected frequencies, which is the theoretical counts based on a hypothesis. And finally, you need your degrees of freedom, which is going to be your number of categories minus 1. So an example of when to use the chi-square distribution would be if you imagine you want to see if a dice is fair, and you roll the dice 60 times and check how many times each number 1 to 6 appears. The expected frequency for each number would be 10. But you can use the chi-square goodness of fit test to compare the observed frequencies with the expected frequencies. Because even though you expect to get all numbers 1 through 6 each 10 times, it doesn't mean that's what you're actually going to get. Next up, we have the t-student distribution. So we want to use the t-student distribution is when you have a small sample size. So this is typically going to only be for samples and not your population. Because if you have a population, that typically means your n would be greater than 30. And because of this, your population standard deviation would be unknown. And when we're doing the t-student distribution, you're comparing the means between two groups, and you're estimating a population mean. So some clues to look for here are a sample size is mentioned and is small, you're comparing means, and the population variance / standard deviation is not provided. And then you want terms like t-test, pair samples, or mean comparison. As well as if there is a square root in the bottom, that would also mean that you're using a t-student distribution. And now some information needed is your sample mean and sample standard deviations, not the population ones. You want your sample size or your number of observations, and you want your degrees of freedom, which is again just n minus 1. So now next up we want our example of when to use the t-student distribution. So the t-student distribution is if you suppose you had a sample of 15 students and you want to compare their test scores before and after a training program. So the hints that we could already see here is that we have a sample of 15 students, not a total population, and we want to compare their test scores. So because we're comparing something and we have a small group, we know we're using the t-student. And then you don't know the population standard deviation, you can use a paired t-test to see if the mean test scores are significantly different before and after the training. And now finally we have the F distribution. So the F distribution is when you're comparing the variances of two or more groups, and you're testing hypotheses about the equality of variances. And it's used in regression analysis to test the overall significance of the model. So some clues to look for are you have multiple groups or samples, you're comparing variances instead of your t distribution where you're comparing means, and then finally it mentions ANOVA, variance comparison or overall model significance. And then finally your information needed is variances of the group being compared, degrees of freedom for the numerator between groups, and the denominator, which is going to be your within the groups, and then sample sizes of the groups. So an example of when to use the F distribution would be, imagine you have 3 different fertilizers and you want to compare their effects on plant growth. So you can already notice that you have 3 different fertilizers, which would mean 3 different groups. So that's a good indicator that we're using the F distribution. And then you have 3 groups of plants, and each group treated with a different fertilizer. You measure the growth of the plants and want to see if there's any significant differences in growth between the groups. And then you can use ANOVA to compare the variances and determine if the differences are statistically significant. And ANOVA would be calculating the group means, calculating the variances, so you would compute the between group and within group variances, and then you want to compute your F statistic, which is the ratio of between group variance to within group variance, and then finally compare F statistic, so you compare the calculated F statistic with a critical value from the F distribution table based on the degrees of freedom. So in the overall summary, we use the chi-square when we have categorical data, frequencies, and independence. We use the t-student distribution when we have a small sample size, unknown population standard deviation, and it's a mean comparison. And our F distribution when we're comparing variances, ANOVA or regression model significance. Some clues to look for chi-square distribution would be observed versus expected frequency, along with contingency tables. Our t-student, you look out for small sample sizes, mean comparison, and t-tests. And then our F distribution, you look out for multiple groups, variance comparison, ANOVA, and model significance. Then for information needed, for chi-square you need observed frequencies, expected frequencies, degrees of freedom. For t-student you need sample means, sampled standard deviation, sample sizes, and degrees of freedom. And finally for F distribution you need variances, degrees of freedom, and sample sizes.